Okay, this is our video of the first midterm diagnostic for units one. Final exam diagnostic for units 1 and 2. All right, so we want to find. So we have these functions presented. We have one as a graph, one as a table, and 3 in formula format. We would like to find the value of 3 of f of t of -1 minus p of r of -2. So here we go. So I'm going to work inside first. I have 3 times f of. Well, I'm going to work on t of -1. That green piece. Well, t of -1, I plug in -1 into t up here, and I get 2 times -1 plus 1, which is -1. So it's -2 plus 1 is -1. So now I have 3 times f of -1. F of -1, I'm going to go to the graph and look at an x value of -1 and read off the y value, and that also is -1. So this is 3 times -1, which is 3. By the way, I hope you're not thinking that every time you evaluate a function, you don't change the number here. It just happens to be that t of -1 was -1 and f of -1 was also -1. So we get -3 there. All right, now I have to subtract p of r of -2. R of -2 I can get from the rule here. R of -2 is 3 minus -2, which is 5. So I have minus p of 5 now. And p of 5 is 5 squared minus 4 times 5, which is 25 minus 20, which is 5. And so I get -3 minus 5, which was -8. Done. Okay, number 2. We want to find the value of f of t inverse of 13. Well, we have to really find t inverse. So if I have y equals 2x plus 1, I want to invert that so I can switch the roles of x and y. So this would be the inverse. And I can solve this for y, so I'll subtract 1 from both sides. I get x minus 1 equals 2y, and divide by 2, and I get y equals x minus 1 over 2. That's t inverse. So now I know f composed with t inverse of 13 simply means f of t inverse of 13. And t inverse of 13 I can get over here by doing 13 minus 1 over 2, which is 6. So now I'm really looking at f of 6. F of 6, I can go to the graph and look for my y value when x is 6, and I get 1. Okay, number 3. It says if f of g of b is -4, I'd like to find the value of t of 2b. Well, okay, so I have f of something as 4, or -4. This is the y value. So this has got to be an x value. Functions eat x's and spit out y's. So this is a y value, and this is an x value. So I know my y value is -4. So I'm looking at my graph of f. My y value is -4, and lo and behold, I get an x value of -2. So I know the something inside this function had to equal -2. Well, the thing that was inside the function was g of b. So g of b now has to be -2. So again, b is my x value, the function's eating it. -2 is my y value. So I'm looking at g of x now and saying, oh, look, there's where you have a y value of -2. So now I know x is 4. So b has to be +4. And then from there, I can go get t of 2b. So t of 2 times 4, that's t of 8. And t of 8 is 2 times 8 plus 1, which is 17. All right, number 4. I want to find and simplify p of t of x. So p of x is x squared minus 4x. T of x is 2x plus 1. And I ultimately want to simplify p of t of x. So p of t of x looks like this. It's p of t of x. P of x is 2x plus 1, so I just put that right in the t spot there. So again, remember, a function is a skeleton. This function rule, P of x, really means P of whatever is the whatever squared minus 4 times the whatever. It's a skeleton. I can replace the x's with parentheses. And basically what this is now saying is that P of 2x plus 1 is going to be the 2x plus 1 squared minus 4 times 2x plus 1. So I can even write my skeleton out, whatever squared minus 4 times the whatever, and take this whatever, okay, I can clone it and put it in the parentheses. Okay, just like that. So that's what P of 2x plus 1 is. So now I would need to expand this out. So 2x plus 1 squared, please don't do 4x squared plus 1. This is a binomial times a binomial. It needs to be distributed. Minus 4 times 2x plus 1. So I get 4x squared plus 2x plus 2x plus 1 minus 8x minus 4. At this point, we get 4x squared. If I simplify my like terms, I have 2x plus 2x is 4x. 4x minus 8x is negative 4x. Plus 1 minus 4 is minus 3. And that's it. Okay, number 5. So number 5 was a multiple choice question off of one of your tests this year. It says, to the right is a graph of y equals f of t, which gives the number of miles walked y after walking for a certain amount of t in minutes. It says, which interpretation below gives the meaning of the equation f inverse of 3.4 minus f inverse of 3 equals f inverse of 0.4? Well, first question you might want to ask yourself, what is the meaning of f inverse of 3.4? Well, f is eating the time. So f eats the time and spits out the number of miles walked. So f inverse eats the miles walked. It switches the roles of x and y. So it's eating the miles walked and spits out the time. So this is really the time it took to go 3.4 miles. Okay? In other words, the time it took to walk 3.4 miles was 60 minutes. So this is 60 minutes. F inverse of 3 is the time it took to go the full 3 miles, which was, if you use the symmetry in the graph, that's 50. Okay? And F inverse of 4, a 0.4 rather, is the time it took to walk the first 0.4 miles, which looks like 10 minutes. Okay. So choice A, it took the same amount of time for the walker to travel the first 0.4 miles as it did to travel the next 0.6 miles. This really has nothing to do with the next 0.6 miles after the 0.4 miles. So that's out. Part B, choice B, it took the same amount of time for the walker to travel any 0.4 mile distance interval along the walk. Well, certainly this is saying that it took the same amount of time to walk the first 4.4 miles as it did to kind of walk from 3 miles to 3.4 miles. But that doesn't mean that that's true for any 0.4 mile distance along the walk. In fact, if I look at the time it took for me to walk from point 4 to point 1, that's 10 minutes. And you actually walked 0.6 miles. So that choice is out from the graph and from what's happening here. Choice C, it took the same amount of time for the walker to travel the last 3 miles as it did to travel the first 2.6 miles. Well, that might be true, but we could actually see that. The last 3 miles would be from 0.4 to 3.4, which is 50 minutes. The first 2.6 miles would end up happening here, which looks like it's at around 45 minutes. So that's out from the graph. And so you're left with choice D. It took the same amount of time for the walker to travel the first 0.4 miles as it did to travel the last 0.4 miles. If I subtract 60 minutes to walk 3.4 miles from 50 minutes to subtract the first 3 miles, I get 10, which is the number of minutes it took to travel the last 0.4 miles. So that's your answer. Okay, number 6. We want to solve for all values of x. We have x minus 4 times something else equals 0. When I have something times something equal to 0, we can set each factor equal to 0. That's the only time that you can do this. The only time you can do this is when you have this 0. So for example, if we had a times b equals 2, or say 24, you could not just say, well, a was 24 or b was 24. That's not true. But when it's times something equals 0, you can say, well, a has to be 0 or b has to be 0. Because if I have two numbers that are not 0 and I multiply them, I get something that's not 0. This is a unique property of the number 0. So what I can do with this is I can split this into two possibilities. I can say, well, x minus 4 is equal to 0, or x to the 4th minus 10x squared plus 9 equals 0. So the first equation is easy to solve. I got x equals 4. The second equation is not as easy to solve, perhaps, and you really have to look for a structure here. So if I'm looking at this, I'm looking at this as a trinomial, and I'm saying to myself, okay, well, if it was x squared, then it would be very easy to do. For example, if it was x squared minus 10x plus 9 equals 0, then I can just factor using the IM method. And you really can do the same thing here. So imagine if I took this red problem for a second and factored it. Or I'll even factor, let's say I'll just call this, I'll just give it another name. I'll call it a squared. So a squared minus 10a plus 9 equals 0. If I factored that, I would get a minus 9 times a minus 1 equals 0, because negative 9 times negative 1 is positive 9, so they multiply to positive 9 and add up to negative 10. Now, I don't have a. So I don't have a squared in that place. What I have is x to the 4th. And if I think about why we put a's here, a times a gives us a squared. So the question is, what could I put in that spot so that when I put it there, it's the same thing, and this thing times this thing gives us x to the 4th? And the answer to that question is x squared. X squared times x squared is x to the 4th. And if you were to FOIL this out again, you would get x squared times x squared is x to the 4th. You would get x squared times negative 1, which is negative x. Negative 9 times x squared, which is negative 9x squared. And that's where the negative 10x squared comes from, and you'd be good with the plus 9. Now I have something times something equal to 0 yet again. And I could set each of these factors equal to 0. And you could solve these in various ways. So I'll just factor. These are very easy. These are dots problems here, difference of two squares factorings. And you can solve them like this. And so I would get x equals 3, or x equals negative 3, x equals negative 1, or x equals 1. So my solution set, I'd have 5 solutions to this equation. I have the 4 from before, I have 3, I have negative 3, I have 1, and I have negative 1, all solutions. By the way, there is another way to solve these equations, so I'll just take the x squared minus 9, for example. You could bump the 9 over to the other side and have x squared equals 9, but when you take the square root, you have to account for the fact that there are 2 possibilities when you take the square root. The square root of 9 is 3, but that's not the only number that solves the equation, so you have to make sure you have plus or minus. Okay, keep that in mind if you like doing it that way. Okay, number 7. So we want to solve for all values of x. We have absolute value of x minus 3 minus 2x equals 1. So I have the absolute value of x minus 3 minus 2x equals 1. Key right now is we need to get that absolute value by itself. So I'm going to add 2x to both sides. So if I have the absolute value of x minus 3, that's equal to 2x plus 1, I have to think about this for a second. Just bear with me. If I had the absolute value of, say, a was equal to 4, there are 2 possibilities. A could be 4 itself, or a could be negative 4. That's what happens with absolute values. So that's exactly what happens here. The thing inside, the x minus 3, could be the positive version of what's on the other side, or the x minus 3 could be the negative of the thing on the other side. That's how the absolute values could be the same. They're either the same thing or they're opposites of each other, and that's what this is saying. So now we can solve each equation for x. So this should be very quick. I'll add, well, let's see. I'll subtract x from both sides here. I get negative 3 equals x plus 1. Subtract 1. I get x is negative 4. Or over here, I'd have to distribute my negative through. So I get negative 2x minus 1 on the right-hand side. I'll add 2x. So I get 3x minus 3 equals negative 1. Add 3 to both sides. So I get 3x is negative 2. Divide by 3. And I get x is negative 2/3. Now, what can happen is that you get what's called an extraneous solution. Absolute values can produce that. So you absolutely need to check these. You have to check in the original equation. So we're going to check in the original equation. The original equation was absolute value of x minus 3 equals 2x plus 1. So I'm going to check my negative 4, and we're going to see something happens. So I get the absolute value of negative 4 minus 3 equals 2 times negative 4 plus 1. Absolute value of negative 4 minus 3 is absolute value of negative 7, which is 7. 2 times negative 4 is negative 8, plus 1 is negative 7. So clearly these are not equal, and so x equals negative 4 is extraneous, and this can happen. And it's pretty obvious why. You're getting negative 7 on the right-hand side, which if I had the absolute value on the right-hand side, then that would be good. But the absolute value on the left-hand side takes away the negative from the negative 7, and it doesn't work. That can happen in absolute values. So this is not a solution. All right, back to the other equation, the other solution rather. I have the same equation. Notice again, I'm checking in the original equation, and my x is negative 2/3. So I have negative 2/3 minus 3, absolute value equals 2 times negative 2/3 plus 1. Yes, you should be able to do this arithmetic without a calculator. So I have absolute value of negative 2/3, and 3, if I multiply by 3 over 3, is negative 9/3. Does that equal this? Well, let's see. 2 times negative 2/3 is negative 4/3. 1 is 3/3. So now let's see if this works. By the way, I'm just realizing that I made a little boo-boo when I went up here, so I'm going to go back. Negative 1 plus 3 is positive 2. Sorry about this. I just made a little mistake here. This is 3x equals 2, and so x is actually positive 2/3. Good thing I caught it now. It would have been better if I caught it before, but such is life. Okay, so this is actually positive 2/3. So let's see. I get positive 2/3 minus 9/3, which is negative 7/3, and the absolute value of that is 7/3. Over here, I get positive 4/3 now. Notice the change, plus 3/3, which is 7/3, and that is equal to the absolute value of negative 7/3. So this checks. So moral of the story here, only solution is x equals 2/3. You need to be on the lookout for that. Big concept. Okay, one more, but it's a long problem. Okay, so consider the function f of x equals 2x squared minus 16x plus 26. I asked you to complete the square to find the vertex. A lot of you struggled with this when we did it. So here it is, once and for all. We're doing it. All right, let's take a look. So I want to complete the square. There are multiple ways to do this. So one way to do it is, first of all, in order to complete the square, I need to have a 1x squared here. not a 2x squared. So I'm going to divide everything by 2. So I'm going to have f of x over 2 equals x squared minus 8x plus 13. And now I need to complete the square. So I'm going to have f of x over 2, and I'm going to complete the square on the x squared minus 8x plus 13. So here's the concept of completing the square. What I'm trying to do is find a number that will create a perfect square trinomial. And the way that's done is you divide the middle coefficient, the x coefficient, by 2 and square that number. So negative 8 divided by 2 is negative 4. So I'll write that up here. I'm doing negative 8 divided by 2, which is negative 4, and then taking the negative 4 and squaring it, and I get 16. So this is plus 16. Now, I can't just add 16. That's not legal. So one way to balance it is I can subtract 16 on the same side of the equation. So I'm adding 16 and I'm subtracting 16. That's legal because negative 16 plus 16 is 0. So what does that do for us? Well, now I have f of x over 2 equals the x squared minus 8x plus 16. And then I can simplify 13 minus 16 into negative 3. Now, why would I do this? Well, the black trinomial factors into a nice factorization. It factors into a perfect square. If you were to factor this, you would get x minus 4 times x minus 4. And that's by design. That's what putting the 16 does for you. So this is now x minus 4 squared minus 3. So now I've gotten this so that I can basically do transformations on it. There's one last step that we need to do here, and then we need to get f of x by itself. So I have to multiply by 2 on both sides. And so I get f of x equals 2 times x minus 4 squared minus 6. A lot of you missed that this is actually a test question. A lot of you missed this. You're multiplying every term by 2. So the binomial is one term, okay? The last operation in that term is the multiplication, and the minus 3 is another term. So they each get multiplied by the 2. So here is your function that you can work with. Now, the vertex basically are the horizontal and vertical transformations. So if I took the original vertex, which for a parabola is 0, 0, my inside stuff says subtract 4. I'm going to do the inverse of that, so I add 4. So 0 plus 4 is 4. Then the vertical transformation stuff, I multiply by 2 and I subtract 6. If I take 0 and multiply by 2, I get 0. If I subtract 6, I get negative 6. So that is my vertex. You could verify that, by the way, using the vertex formula. So if you're not sure of what that looks like, your vertex formula is x equals negative b over 2a. And so I get negative b, I'm looking at my original, so my b is negative 16, so I have the opposite of negative 16 over 2 times a, which is 2. So I get 16 over 4, which is 4. That jives exactly with my x-coordinate. My y-coordinate, I would plug in 4 into the parabola. So f of 4 is 2 times 4 squared minus 16 times 4 plus 26. 4 squared is 16 times 2 is 32. 16 times 4 is 64. So 32 minus 64 is negative 32 plus 26. I get the negative 6 that I had here. So you can use the formula for the vertex of the parabola to verify that, but I'm asking you specifically to complete the square. Okay, so now I have part B, which I'm actually going to cut and paste into a new document here. Here's my part B. I would like to use my transformations of functions and work of part A to make a graph. So my original graph, so now I've transformed my function to this. F of x is 2 times x minus 4 squared minus 6. So I know this is a transformation of x squared. Stuff's just being done on the inside and the outside x squared. So I'm going to graph x squared. My parabola 0, 0 has 1, 1, and negative 1, 1, 2, 4, and negative 2, 4, and 3, 9, and negative 3, 9. There it is. That's my parabola. So now I want to take that parabola. I'm going to do my horizontal transformations first. The horizontal transformations are the inside stuff. Inside I'm squaring, I'm doing minus 4. So what does that do? Well, it shifts 4 to the right. I have to invert inside stuff. So my horizontal shift is 4 to the right. So here's my original function. I'll clone it. It's my original function. And I'd like to shift that 4 units to the right. 1, 2, 3, 4. There it is. My vertical shift is the outside stuff. So I multiply by 2 and subtract 6. That's going to vertically stretch the function by a factor of 2. And it's going to shift the function down by 6. So I'm going to do that to each point. So I'll take this guy, the vertex, right now. 4, I'm going to multiply by 2. The y value is 0, so 0 times 2 is 0. And then I'm going to subtract 6. So that goes down 1, 2, 3, 4, 5, 6. And that's our vertex that we got before. Again, it all should agree with each other. Okay, I'll do that to 5, 1, and 3, 1. So I'm going to multiply by 2. So that's going to get me up to 2 for both of them, and subtract 6. 2 minus 6 is negative 4. So now I'm here and I'm here. And notice the hope you're seeing the parabola not only shifted, but it's stretching in a vertical direction. Okay, so I'm going to do that with my points at 6 and 2. So I'll multiply by 2. 4 times 2 is 8. 8 minus 6 is 2. So at 2, I'm going to have a height of 2. At 6, I'm going to have a height of 2. And last but not least, I can do it with these points. My 7, 9, and my 1, 9. So I'll multiply by 2. That's 18. 18 minus 6 is 12. So I'm here and there. And you'll get a very nice parabola that I hope you see has now stretched as well. So it's moved down and stretched. The vertex is at negative 4, 6, as we said it would be. And you don't need to do the explanation of the transformations because we graph them step by step. Okay, back to my original questions here. Part C, I believe, asked us to state the range. So let me actually cut this and move it over. Cut, move it over to here. All right, paste this in. So I'm stating the range of this graph. So my range is, well, you can see it from the graph. It includes negative 6, but doesn't go below negative 6, and goes as high as I like. Remember, the parabola goes on forever here. So that's my range. I would like to label the location of the roots on my graph. The roots are where the graph intersects the x-axis. That happens at these green points. So to estimate the values, well, I'm looking, I'm like, it looks like 2.4-ish or 5.6-ish. Again, these are estimates. I'm just looking at the graph and saying, all right, here's what I think. And then the next question says, I would like to find the roots using any algebraic method I wish. So the roots are when I'm setting the equation equal to 0. Basically, what I'm saying is the y is equal to 0. The y is equal to 0. It's the same thing. I want to get the values of those points. And here I'm going to use the quadratic formula. Okay, because we haven't used it in a while. So x equals negative b, so that's 16, plus or minus the square root of negative 16 squared minus 4 times a times c over 2 times a. By the way, I could have made this a lot easier by dividing everything by 2 as well. But I just wanted to show you in case you just kind of went through this like this. So x is 16 plus or minus square root of 256 minus, let's see, I gotta do this quickly. So 26 times 2 is 52. 52 times 4 is 208 over 4. X equals 16 plus or minus So 256 minus 208 is 48 over 4. So I get x is 16 plus or minus. Now I want to get this to simplest radical form. So I have to simplify my radical 48. Easiest way is to get this down to a perfect square. So I have 16 and 3. Square root of 16 is 4. So I have 16 plus or minus 4 radical 3 over 4. Okay, and now I have x equals, if I divide everything by 4, I would get 4 plus or minus radical 3, which it might be helpful to put this in the calculator just to see. Radical 3 is about 1.73. And you can put that in the calculator if you don't trust me on that. But if I just approximate this, I approximate 4 plus radical 3 by doing 4 plus 1.73. I get approximately 5.73. And I get approximately 4 minus 1.73, which is about, say, 2.27. And that's pretty close to my guesses from before. I had 2.4 and 5.6 just eyeballing it off the graph. So I'm pretty close. All right, that's it for this video.